Hello guys, welcome back once again. We look into the problem 2. So the problem 2 which is given is on source follower. We know source follower is nothing but common drain configuration, common drain amplifier. Now let us draw the circuit. The output is taken from the source terminal, the input is applied to the gate, and drain is directly shorted to VDD. So they have mentioned the load resistance RL, which is of value 2 kilo ohm. Use saturate, and they have given a statement like use saturated MOSFET as a current source, meaning for this they are use saturated MOSFET, meaning MOSFET in saturation region. And VDD 5 volts, ID 300 microamperes, and Vout 3 volts. Board drive voltage of all the MOSFETs is 0.15 volts, and lambda is non-zero, which is 0.1. Lambda is 0.1, it is non-zero, this is channel and modulation effect. And also gamma is 0.6, is non-zero, body bias effect. Body bias effect is present in the circuit. So, and 2πf, which is 0.8, and threshold voltage is also given, VTHO, and length. There is no width which is mentioned. So they are asking us to find the gain of the NMOS source follower. So we know the gain of NMOS source follower is given by GM divided by GM plus GMB. So now let us find what is GM and GMB and substitute back so that we will be obtaining gain. So we know that transconductance is given by the formula GM equal to ID by 2 VOV. We usually write GM, which includes body effect also, body bias effect. But actually when there is a body bias effect, we have to indicate by GM dash. Since in this circuit we have body bias effect, so we are indicating by GM dash. But usually for our convention, instead of writing GM dash, we usually write as GM. So GM dash, which is nothing but GM plus GMB, is ID divided by 2 VOV, because ID is also a function of VGS as well as VBS. So VBS is nothing but body effect. This is coming due to the body effect, and VOV is also somehow dependent on VBS. So this is also due to the body effect. So when ID and VOV are depending on body bias effect, inherently GM dash also would depend on that. So now let us try to find GM and GMB. So GM is given by mu n Cox W by L VGS minus VT. We know that W is not given in the question, so we cannot use this equation. So GM, there is another equation which is 2 mu n Cox W by L ID into ID. So again there is a W, so we cannot use this equation again. So we are left with since we are not able to find the GM, so we have to somehow obtain GMB. So that's the only option. We know GMB is how drain current changes with respect to body to source voltage, like how transconductivity is different, how drain current is changing with respect to VGS. Similarly, GMB is defined as how exactly drain current is changing with respect to body to source voltage. So this acts like a primary gate of MOSFET. Similarly, this will act like a secondary gate, even though its effect is minimal compared to primary gate. So this will act like a secondary gate. So equation of ideal substitute here, half mu n Cox W by L VGS minus VT whole square, and also we have to include the channel in modulation effect, which is 1 plus lambda VDS. So when I differentiate, so these all are constant, which doesn't change with respect to VBS. The only thing which changes is the threshold voltage, because threshold voltage is a function of VBS. Rest all are constant. This is also constant, which doesn't change with respect to VBS. This is also constant. So half mu n Cox W by L 1 plus lambda VDS into, since VT is changing with respect to VBS, so I have to differentiate this VT. So differentiation, after doing the differentiation, which is 2 into VGS minus VT into minus VT dou VT by dou VBS. So 2 and 2 I can cancel. If I clearly see, this is nothing but the expression for mu n Cox W by L into VGS minus VT times 1 plus lambda IDS. This is nothing but the expression for GM. So this is GM into dou of VT by VT or VTH, whatever it is, VTH VBS, or we can write it as GMB equal GM into, we can eliminate this minus by dou VTH divided by dou VSB, since dou VTH by dou VBS is equal to minus of dou VTH by dou VSB. So we are able to express GMB in terms of GM. Now we have to find what is this, what does this evaluate to. So let us find that. So let us write the threshold voltage expression, which is VTH is equal to VTH O plus gamma times of 2 phi f plus VSB minus 2 phi f. So we have to differentiate this VTH with respect to VSB. So this is a constant which will come as 0, because it is not changing with respect to VSB. The only parameter which changes with respect to VSB, the parameter itself, that is VSB here. So gamma times of, so square root function, we know that differentiation of square root of function is 1 by 2 root of that function, 2 phi f plus VSB. and also this is also not changing with respect to S, so differentiation with respect to VSB would be 0. So finally we got VTH by VSB. So I'll be substituting this VTH by VSB into this equation which we obtained. So GM into gamma divided by 2 times of 2 phi f plus VSB. So if we can recall the expression, which is GM plus GMB is equal to ID by 2 VOB. So we are able to express GMB in terms of GM, so that we can obtain either GM or GMB, and substitute the final equation into the gain equation, and we will be obtaining the gain. So GM plus GMB is equal to 2ID divided by VOB. So GM, so just now we obtained GM in terms of GMB in terms of GM. So GM times of gamma divided by 2 in times of 2 phi f plus VSB is equal to 2ID divided by VOB. So we know the values, these values, which is 2 into 300 micro divided by 2ID. Overdrive voltage which is given is 150 millivolts. So when I evaluate this, so GM, this would come around as 4 millisiemens. So GM 1 plus gamma divided by 2 into 2 phi f plus VSB equal to 4 milli. So in order to find GM, 4 milli divided by 1 plus, so we know gamma value is 0.6, which is given in the question. 2 times of 2 phi f value is 0.8, and VSB, V source minus V body. So in NMOS, V body is always connected to ground. Vs, we have to find what is the value of Vs. So we have to find what is the value of the Vs. Since this is the source terminal, so this is where we are taking the output. So Vout they have given in the question as 3 volts, so automatically this would be the value of Vs. So we got Vs as 3 volts, so that is also the same as VSB. So this would, VSB would be 3. So when we evaluate, this would come around as 3.4665 millisiemens. So finally the gain of common source amplifier, common source follower amplifier is GM divided by GM plus GMB. So we obtain GM 3.466 millisiemens, and GM plus GMB we obtained as 4 millisiemens. That is nothing but the same 2 into 300 micro VOB. So this would come around as 4 millisiemens. We just evaluated here. Four millisiemens. So gain finally would be 0.867 volts per volts. So this is what which was asked in the question. Thank you guys.